Alrighty, here we are on lesson 3, distinguish measures of center from measures of variation. So yesterday in our lesson we talked about mean, median, mode, and range, but now today we're going to talk about deviation, and deviation is how far a data point is from the mean of the data. Data values to the left of the mean will have negative deviations, and data values to the right of the mean will have positive deviations. So again, deviation is pretty much how far away it is from the mean. So to start, they ask us to draw a line plot using the following numbers. So I'm going to look at my list here, and I see I just have 9 through 13, so I can just do singles. So I'm going to have a 9, 10, 11, a 12, and a 13. And then I'm going to put my dots on here, so 9 gets a dot, 10 gets a dot, 11, another 11, 12, and a 13. Okay? So, in order to find the deviation from the mean, we first have to calculate the mean. So again, to calculate the mean, we would go ahead and add all these numbers up. So we're going to add up 9 plus 10 plus 11 plus 11 plus 12 plus 13, and that gets us 66. So our mean is 66 divided by how many numbers we have. So 1, 2, 3, 4, 5, 6 numbers. So our actual mean is 11. So I'm going to go ahead and put a little star underneath this 11 here. Okay, that's our mean. So now, deviation from the mean, remember, is how far away it is. So if we look at 9, that is 2 spots to the left of 11, so that's going to have a negative 2 deviation. A 10 would have a negative 1 deviation. And now our 11s would just be 0 because they're on it. They are on that mean. 12 would be a positive 1 deviation because it's 1 to the right, and 13 is 2 to the right. Okay, so now one thing that I want you to add in here is the sum of all these numbers. So negative 2 and negative 1, this would be negative 3, 0 here, and then 1 and 2, this would be positive 3, so these cancel each other out, so our sum would be 0. Okay, so just keep that in mind, and we'll come back to that in a little bit. Alright, so go ahead and go to the next page, example 1. Michelle asked 10 of her classmates for the number of hours they usually sleep when they're at school the next day. Their responses in hours were this list of numbers. So first we need to draw a dot plot. Again, take a look at your number set. My lowest is 7 and my highest is only 11. So I can count by ones. 7, 8, 9, 10, 11, and I'll put an extra on there. So we got to do our dots. So 8, 10, 8, another 8, 2 11s here, a 9, another 8, another 10, and our 7. Okay, so again, we would have to find the mean. We'd have to calculate it by adding up all of the numbers and dividing by the amount of numbers we have, but they gave it to us down here. They say if 9 hours is the mean, so I'm going to put a little star under the 9. Show the deviation from the mean for each data point. So if 9 is our mean, 8 is 1 spot over, so to the left, so this would be a -1. 10 is 1 spot to the right, this would be a +1. 8 hours would be a -1. We've got another -1 here. 11 is 2 to the right, so it would be a +2. Got another +2. 9 hours would just be a 0 because it's on the mean. 8 is -1. 10 would be a +1. And then 7 would be a -2. Okay, so again, it asks us to find the sum of the deviations. Well, if we start looking here, let's see. These two cancel. These give us 0. If we look here, this is a -2. 2 positive 2, so it gives positive 4. 0, these 1s give us another 0, and then we've got a negative 2 here. So we have 2 negative 2s and a positive 4. Those cancel each other out, so again our sum is 0. Alright, so go ahead and flip to the next page. In the box it says the mean is the point that balances the sum of the positive deviations with the sum of the negative deviations. It can be defined as the value that makes the sum of all deviations in a distribution equal to 0. So that's what we talked about when we found our sum. Does it equal 0? And we were trying to figure out why or why not. Well, that is why. That's what the mean is supposed to do. Alright, so we're going to do one more here. Example 2 says Maria's food pantry gets many donations of fresh lemons. She needs to put them in bags of 8. She's going to be able to make 8 bags using all of the donated lemons. There were 8 donations. The smallest donation was 4, and the largest donation was 15. So first, how many lemons were donated in all? We know she's going to make 8 bags of 10. Right, so 8 times 10, this would be 80 lemons in total. Alright, the mean number of lemons donated, so we're going to take that total, and we're going to divide by how many bags she can make, which is 10, so our mean would be 8. So now it says create a dot plot that could show the 8 donations. So we're not sure. Alright, we only know a few. We know the smallest donation was 4, and the largest donation was 15. And then we know our mean is 8. So we're going to list all the numbers from 4 to 15. Let's go ahead and do that. Okay. And then we're going to put the dots on the ones that we do know. So we do know that there was one that was 4 lemons, and one that was 15. Okay, so now the trick is that we need to balance these out, okay? And we know that the mean was 8. So if we put down our first 2 numbers, we know that the one donation was a 4. And what's the deviation from the mean? Well, our mean is 8, so this would be our mean is not 8, sorry. That's what I was confused. So erase that star under the 8. Our mean is 10. This makes more sense. So if our mean is 10, the deviation for 4 would be minus 6. Okay. And then we know we have a 15, and I'm going to put that all the way down here at the bottom. And we know that the 15, the deviation would be a plus 5. Okay. So we're trying to figure out how we can balance this out. So we know we have a minus 6 up here at the top, and we only have a plus 5, so we want to get a plus 6. So we want something with one deviation. One deviation from 10 would just be 11. So we know that this balances out to plus 6. Okay, so go ahead and put a dot on 11. And since it's already balanced, we can just put the rest of them on 10. So 10, 10, 10, and 10, because our deviations would all be 0. So then it would all be balanced. Okay, so our sum then would be 0. Okay, so there's more than one way to do that, and we'll talk about that a little bit more in class. We're going to save that last example for during class. So that's all we're going to do for this video.